Good morning, everyone. My name is Beatriz Martin. The article we're presenting today in this conference was developed by myself and my colleagues Carlos Franco and Ángeles Perianes, who will continue with the second part of this brief presentation. We are all architects and work as researchers at the Technological Institute Intromac, located in Cáceres, Spain. Our presentation today is about the experimental demonstration results and environmental monitoring of energy retrofitting actions on the twin houses EDEA CICE through European projects. First, I'll explain what EDEA CICE actually is, and then my colleague Ángeles will continue by talking about the results from experimental demonstration activity carried at EDEA CICE facilities through two European projects, ReNatural and ENCORE. First of all, what is EDEA CICE and what is it for? Well, EDEA CICE is the Innovation and Quality Center for Buildings of the Extremadura Regional Government, located in Cáceres, Spain, and it is managed by Intromac. It originated from two European projects, EDEA project and EDEA RENOV project, both from the LIFE program and awarded in their respective calls. As we can see on the slide, the center consists of two identical houses, or twin houses, that serve as a full-scale and real-time demonstrator, especially for sustainable construction and energy efficiency technologies. As I told, EDEA CICE is a research infrastructure that consists of two identical uninhabited experimental houses developed with social houses characteristic typical of the region of Extremadura, the reference dwelling and the experimental dwelling with north-south orientation. In the second one is where technologies to be tested are implemented, while the reference one remains unchanged, allowing us to compare their performance. Between these two houses, there is the equipment and facilities common room with various climate control and ventilation strategies that serve both. Finally, there is an interpretation center with a roof where are located the solar and aeolic energy system, as we can see here in this picture. The purpose of this infrastructure is to facilitate researchers and manufacturers the study and experimentation of their innovative solution on a real scale and under the same real conditions towards a more cost-effective, sustainable and higher quality buildings and housings. The most important to make this real-time experimentation and comparison between the two houses possible, EDEA CICE has a complex remote monitoring and management system. This system includes its own weather station, as we can see here in this picture. And is equipped with more than 800 sensors in the houses and strategies, which allow us to collect every real-time data. Some of these sensors are electricity consumption, ambient temperature, surface temperature, relative humidity, CO2 concentration, heat flux, or water flow and temperature in thermal systems. This enables us to control the environmental condition during the test or scheduled interventions, and it also allows us to compare analysis of passive and active strategies and the use of renewable energy by observing the energy performance of the experimental dwelling against the reference one. Also, we can easily connect to this control system remotely to visualize, compare, and measure environmental condition and thermal behavior in real time, obtaining graphs or measure parameters to do the studies. To finish with this part, in this slide, we show the active strategies we have at the center and their control system. These strategies are biomass boiler, ground-to-water geothermal system, solar thermal energy, aerothermal energy, evaporative cooling, ground-to-air geothermal system, photovoltaic solar energy, and aeolic energy. This system allows us to select and combine different strategies using various terminal units, establish set points, and schedule for system operation. For example, here we can see the ground-to-water geothermal system screen. We display data on water flow at temperature through the hydraulic network and storage tanks.
Now we briefly explain some experimental demonstration activity developed in EDEA CICE through live program project called ReNatural, recycle natural materials and products to develop nearly zero energy building with low carbon footprint. With this project, sustainable building solutions close to the market has been firstly test in a laboratory characterization of all these natural materials like compressed earth block, cork, cellulose, bio-based materials in a laboratory scale. Afterwards, this has been these materials have been used in prototypes in EDEA CICE at real scale, and afterwards in the final demonstration, these bio-based building solutions have been implemented in the renovation of real housing and also in new construction. The purpose was to promote sustainable construction and to build prototypes that reduce the energy demands using these natural and recycled materials. If we focus on the activity carried in EDEA CICE demonstrators at prototype scale, different renovation activity has been carried out in the north facade of the experimental demo house. The first phase is the one that has the reference demo house made of fabric, 5 centimeters of rock wool and the finishing layer. This is the building solution that has been used as reference in the initial phase to compare with the different improvements carried out. For example, in the first, the next phase has been to blow in the air chamber different isolation materials, and after this phase, the demolishing of part of this north facade has been done to rebuild it with compressed earth block with different widths and isolation materials. So we had been analyzed and studied each one of these bio-based building solutions. Here you can see some images of this different implementation of bio-based building solution. One adding an external thermal isolation system with 8 centimeters width of cork. A different bio-based solution had been to blow recycled cellulose insulation in their chamber. And then finally with this demolition phase and rebuilding with the compressed earth blocks and then analysis of the improvement with the different kind of natural isolation materials. Each of these bio-based building solutions had been analyzed this performance test, including acoustic, thermal transmittance, air infiltration, infrared. So to verify what kind of deviation in compare to the reference demo house and the initial phase building solution. And here are some more of the results from the continuous monitoring data. For example, here in this graph, you see the different phases and how these external thermal and humidity conditions influence in the different tests. In 3 different rooms, here we see for example, the leakage performance, the air tightness in each of these rooms in comparison from the initial phase, building construction phase, to the different improvement. In this case, we see that the final phase performance is worse than the initial one. This is probably due to this rebuilding of the envelope, the demolition and rebuilding afterwards had worse quality during these works. We know this is very brief resume of results, but you may find all the detailed information in the website. Is public published material you can access easily find at the website. This is another project where EDEA CICE demo houses has been used, in this case, to test how digital tools can help us to improve the renovation process, combining the experience and decision making of the different stakeholders involved in a renovation process, and supporting smart renovation workflows. During the ENCORE project means energy aware BIM cloud platform in a cost-effective building renovation context. As I mentioned, it is analyzed the whole flow of the renovation process, and for example, in the designing phase, is like the first phase of a renovation process. It is test the experience of the digitalizing agents. It's been used LiDAR technology, point cloud. It's been generated and transformed into the 3D model that has been calibrated with the real model, with the real construction. During the execution phase of this renovation process, another digital tool has been tested in the EDEA CICE. Its name is Olonic Construction Management System. During this demonstration, the experimental demo house has been used to develop deep retrofitting works, both in the envelope and also in the system. In this case, the digital tool is inspired in decentralized manufacturing, enables flexible and self-organized project management, and allow dynamic scheduling, real-time resource allocation, and material tracking based on the current site conditions and using smart sensors at EDEA CICE. This other digital tool involves the stakeholders to facilitate the decision making during this renovation process. Here you can see in the pictures, for example, different tags installed on the first floor of the EDEA CICE experimental demonstration. with this tool, volunteers, in this case were technicians from the projects, had the opportunity to test the digital tool and perform their assessment using HoloLens. In this case, the purpose is to improve renovation design quality by mixed reality application for on-site assessments. The tool is based on immersive visualization, integrates BIM-based platform, HoloLens, compatible with mixed reality viewer, and this NFC-based spatial location. Finally, all these results have demonstrated that this type of digitalization tools allows the optimization of the different phases of retrofitting process, anticipates conflicts and provide transparency to the process. This is all for now. You can contact us through our emails or get more detailed information through the website and social networks. You are invited to visit us in the EDEA CICE facilities. We will be very happy to show you this infrastructure. Thank you very much for your attention.